In this video, I am going to show the proof of gamma of 1 by 2 that is equal to root pi. For that, let us recall the definition of gamma function. Gamma function defined as gamma of z that is equal to integral 0 to infinity t power z minus 1 times e power minus t times dt. Using this definition, I am going to prove that gamma of 1 by 2 that is equal to root pi. Further, let us consider t power z as y. If t power z equal to y, then if we do the derivative of x power n, the formula is n times x raised to the power of n minus 1, isn't it? So if we do derivative of this, then we will get n times, which is z times t of z minus 1 times dt, that is equal to dy. So from here, t power z minus 1 dt equal to 1 over z times dy, isn't it? So we got this t power z minus 1 times dt. We need to find out this e power minus t value. That means we need to take exponential on both sides. So e power t power z equal to e power y. And also in the power we have minus sign. That's why we need to take in our expression both sides we need to take negative. So here negative and here negative. We have only e power minus t term. We don't have t power z. So that's why both sides in the powers multiplied by 1 over z. Z cancels. So e power minus t that is equal to e power minus 5 whole power 1 over z. After doing some simplification, we got this. Now substitute this in our gamma function. We defined as gamma of z equal to integral of t power z minus 1 e power minus t dt. This is our gamma function. We consider t power z equal to y. So after considering this, we convert it into y terms. T power z minus 1 times dt, that is 1 over z times dy. 1 over z times dy. E power minus t, that is e power minus 5 whole power 1 over z. We need to prove gamma of 1 over 2. That means we need to take z value as 1 over 2. So let us consider z as 1 over 2. Gamma of 1 over 2 that is equal to, here we need to substitute 1 over 2. So integral 1 over 2, which is 2 only. So just take only 2. E power, what we have? We have e power minus y whole power 1 over z. So we are substituting z as 1 over 2. That means e power minus y whole power 1 over 1 over 2 is equal to e power minus y whole power 2. So instead of e power minus y whole power 1 over z, we can write it as e power minus y power 2. So what we get? Constant, take it front. So 2 times integral 0 to infinity e power minus y over y power 2 dy is considered as equation 1. This is in terms of y. If you take in terms of x, we get gamma of 1 by 2. So we are going to get into the same thing, only instead of y, we have to write x. E power minus x raised to the power of 2 dx. Consider this as equation 2. Now what we do? Multiply 1 and 2 equations. First equation is gamma of 1 over 2, that is in terms of y, times gamma of 1 over 2, that is in terms of x. That is equal to, what we have? We have 2 times integral 0 to infinity e power minus y over 2 dy. Again 2 times integral 0 to infinity e power minus x raised to the power of 2 dx. Here we have constant 2, here we have constant 2. And left hand side we have gamma of 1 by 2 and gamma of 1 by 2. Here we are going to get gamma of 1 by 2 whole square. Here 2 times 2 we get 4. And we have 2 integrals, that is 0 to infinity, again 0 to infinity, and we have what we have? E power minus x raised to the power of 2 times e power minus y raised to the power of 2 dx dy. When bases are same, we can add the powers. So using that property here, so we can add these powers plus y power 2. Now observe x raised to the power of 2 plus y raised to the power of 2. In polar function, x raised to power of 2 plus y raised to power of 2, the value is r power 2, isn't it? Because in polar function x value is r cos theta and y value is r sin theta. So if we do r square, take it as common, then cos square theta plus sin square theta, which use 1 only. So 1 times r square, which use only r square. So in polar form, x power 2 plus y power 2, the value is r power 2. So we are changing into polar function. So we are changing this as polar function. That means also we need to change, isn't it? And also this x and y, we need to change with respect to theta and r. We are changing completely into polar function. So then that is equal to 4 times the dx dy. If you do with respect to theta, then it convert into r d theta dr. So now substitute in our gamma function. So gamma of 1 by 2 whole square, that is equal to 4. So we are changing only with respect to theta. That means we need to change only the first integral, which is 0 to infinity. It convert into 0 to pi by 2. Still we have another integral that we are not changing here. We keep it like that only. Then e power x raised to power 2 plus y raised to power, the value is r power 2. That is e power minus r power 2. And we have dx times dy. After changing with respect to theta, it convert into r d theta dr. We split into two parts. One is for this integral is for d theta and this integral is for dr. 4 times this is for theta, right? So you just take integral 0 to pi by 2 d theta. This integral for r. So just take 0 to infinity r e power minus r power 2 dr. For integral 0 to pi by 2 d theta, the value is theta. If you apply the limits, then we can get the upper limit is pi by 2 minus lower limit is 0. So that is equal to pi by 2. So after applying the limits, we got this as pi by 2. Still we need to find out this 0 to integral r times e power minus r power 2 dr. Let us consider r power 2 as some variable, just like p. Then if we do derivative of this, then you will get 2r dr, that is equal to dp. We have r dr, so let's take only r dr, that is equal to 1 over 2 dp. Now just substitute here, then you will get 0 to infinity e power minus r power 2, that means minus p, r dr is nothing but 1 over 2 dp. So we can write this as 1 over 2 constant. I write it first, then 0 to integral e power minus p dp. Integral of x dx, the value is e power x only, but here we have negative in the power, so we will get 1 over 2 minus e power minus p. So then I will get 1 over 2 minus of, if you upper limit, that means e power minus infinity, which is 0 only, minus lower limit. E power 0 is nothing but 1. This 0 minus 1, the value is minus 1. Minus and minus plus, which gives plus 1. So plus 1 times 1 by 2, which gives 1 by 2. So after solving this, r times e power minus r power 2 dr, the value is 1 by 2. Substitute here, the value is 1 by 2. Here 2 times 2 gets cancelled. So gamma function of 1 over 2 whole square, that is equal to pi. If you take square root on both sides, then you will get gamma of 1 by 2, that is equal to root pi. So hence we proved that gamma of 1 by 2 equal to root pi. That's it.